Hi, in this video we're going to talk about integrating 1 over x. Okay. Now if you recall, when we took the derivative of the natural log of x, we actually ended up with 1 over x. Similarly, if we take the derivative of natural log of u, we end up with the derivative of u divided by u. So it only follows that if we integrate 1 over x, we will end up with the natural log of x. And if we integrate 1 over u and we have the derivative of u, we will end up with the natural log of u. Okay? So to show you how this works in applied, we're going to do a couple of examples. In this one, I'm taking the integral of 1 over 2x plus 5. Got my dx. Okay? Now, notice that I have to have, if the bottom is my x, I have to have the derivative of that. So the derivative of 2x plus 5 is 2, so I'm going to add that. Now when I add the 2, I need to also add the 1/2 so that I don't change it, because 2 times 1/2 is 1, so I haven't changed it. All right? And so now I have my derivative here, so I'm set to integrate. I'm going to end up with the 1/2, and now if I'm treating this as 1 over x, it's simply going to be the integral of 1 over x is just the natural log of the absolute value. In this case, my x is 2x plus 5, and then I need to add my constant. Let's do another example. In this example, if I treat my denominator as the u, or the x, then I need the derivative of this. So the derivative of x cubed minus 3x squared is going to be 3x squared minus 6x. In the numerator, I don't have that, but I have x squared minus 2x. I notice that they only differ by a multiple of 3. So again, I'm going to multiply my numerator by 3, so I need to put my 1/3 out here. And now if I want to, I can rewrite this as 1/3 the integral of 1 over x cubed minus 3x squared. And then over here I'd have my 3x squared minus 6x dx. Here is my derivative. So now I can just apply the second formula, and when I integrate 1 over u, I will end up with 1/3 natural log the absolute value of x cubed minus 3x squared plus c. And now I caution you, with all new things we learn, we want to apply them right away into every situation, but here's another example of where we might not need to apply it. Okay? Now I notice that it kind of looks a lot like 1 over x, and I could certainly go down that avenue, but go back to what you've already learned. You can rewrite this as the integral of x plus 1 to the negative 1/2. Okay? I have the derivative of x. It's just 1. Okay? Okay, so don't make this harder than it has to be. Our old rules just apply. Okay? Where I integrate x plus 1 to the negative 1/2. Okay, I'm just going to add 1 to this, so that gives me x plus 1 to the positive 1/2, and then I divide by 1/2 plus my c. And notice that when I divide by the 1/2, I can actually bring it 2 out front, so I can rewrite this 2x plus 1 to the 1/2 plus c. And so notice that even though I'm dealing with 1 over something, 1 over my x is in the denominator, I did not need to apply the natural log. So keep that in mind. I guess more formally I could write this 2 square root x plus 1 plus c. Hope this helps. I'll do a couple more examples in the next video.